Hello and greetings, everyone. Our association with Corning started last year with the intent to create a unique series on innovations in clean air technologies, featuring dialogues and discussions with experts from Corning Incorporated as well as the industry. It is interesting that we are gathered here once again for a discussion on emissions, air quality, and health, why you should care today. In fact, it's interesting because it happens to be Earth Day today, an annual event observed on April 22nd each year to demonstrate support for environmental protection. The official theme for 2022 is, in fact, invest in our planet. Our partner for this series, Corning, as you would all know, is one of the world's leading innovators in material science, with a 169-year-old track record of life-changing inventions. Corning is committed to researching, developing, and engineering environmental products that improve the quality of the air we breathe. The company creates ceramic substrates and particulate filters that form the core of world-class pollution control systems, from light-duty passenger cars to heavy-duty trucks and construction equipment. On December 17, 2021, we had our first dialogue of this series with Dr. Willard A. Cutler, Division Vice President and Commercial Technology Director at Corning Environmental Technologies. Corning partners and works with OEMs to develop new technologies that then allows it to reduce the gaseous emissions of the particulate emissions that allow for new regulations. Dr. Cutler, in his dialogue, also stated that while commenting on the transformation in the mobility ecosystem from ICEs to EVs and other alternate and greener propulsion technologies, he said there are a number of challenges to get from where we are today to where we would like to be in the future. India, for example, Dr. Cutler said, is quite fortunate in that most of the technology needed to meet both the current regulations and the future regulations has already been invented, because regulations typically cascade from Europe to other parts of the world. The other important thing that he said was, if the US moved to 100% BEVs by 2040, the reduction in the particulate in tons was only about 17%. And that this was found by a Corning study. So those vehicles sold between now and 2040 are going to be producing emissions for many more decades to come, Dr. Cutler noted. The good thing, though, is that there is technology today to dramatically reduce pollution across IC engines. Our second session in February this year, we had Dr. Ameya Joshi, Director, Emerging Technologies at Corning Inc. And the subject we discussed that day was on global trends and regulations in clean air technologies. The theme across the world is to ensure that the vehicles emit the same on the road as they do at test laboratories. And to reduce the non-conformity factor, it is necessary to have good instrumentation to measure on-road and developing technologies to meet these requirements, Dr. Joshi had said. Besides, it is necessary to ensure that the lab test cycles represent real driving. In the dialogue on global trends and regulations in clean air technologies, Dr. Joshi also said that the main focus should be on cold start emissions. Critical factors are ensuring that the emissions during the first few minutes of the car running are identical as they do after the engines warm up. And these can be achieved by improving standards and technologies, he had said. Ladies and gentlemen, the third session today in this series is on emissions, air quality, and health, why you should care. And it's an absolute honor to have with us Dr. Thorsten Boger, Commercial Technology Director, Light Duty Products, Corning Environmental Technologies, Dr. Mukesh Sharma, Fellow, National Academy of Engineering, member, WHO Advisory Group on Air Pollution and UN Sustainable Goals, and Professor of Civil Engineering at the Indian Institute of Technology, Kanpur. Our third guest today is Mr. Sudipto Basu. He is the Executive Director at Emission Controls Manufacturers Association, ECMA. Ladies and gentlemen, we shall start with a presentation by Dr. Sharma, followed by a presentation by Dr. Boger, and of course, Mr. Basu. At this stage, I would also like to remind all our participants today that you have an opportunity to interact with our speakers. So if you do have questions, please use the Q&A box at the bottom of your screens to send in your questions, and so that I can pick them up towards the end of our session today. So to begin now, I would invite Dr. Sharma for his presentation.
Well, good afternoon to all my fellow panelists and also to the participants who are on board. And going into the few things that I want to talk to you is about the vehicular pollution and what we need to do in order to make the maximum benefit of certain actions which we have already taken, how to maximize those benefits. So if you allow me, I could share a few slides, please. So just let me make sure that. So I hope.
Your screen is visible, Dr. Sharma. If you can please go to the presentation mode.
Wonderful.
Yes, perfect. Thank you.
So well, as I said that, well, we have issues regarding the emissions and pollutions you've briefly talked about. But see, the point is we also have taken certain actions, certain investments we have done, but we also have to make sure that the investments translate into more maximum benefits. So one of the things, while the technology has progressed tremendously, but there's a need as to how do we examine and how do we evaluate our vehicles that should come on the road. And briefly, Deepangshu, you did mention about the driving cycles. And now we have to go beyond the driving cycles, get into the mode of real driving emissions as to what happens when the vehicle is on the road and simply not, being tested in the laboratory. So that requires certain, the procedures, certain guidelines, and also, what are the policies that we need to have so that we have the maximum benefits that would accrue out of the investments that we have done. So moving ahead with that, the first slide, which briefly we all understand, but still to have a little background, the issue of the air pollution is a global issue. And interestingly, the WHO has come up with the new guidelines as far as the pollution is concerned, especially PM 2.5. And the statistics are that 99% of the population is not meeting or they're exposed to the guidelines which are above the WHO recent guidelines actually. So it means the problem is not only at the developing countries, but also the developed countries also have the new challenge. And obviously the pollution levels, as you can see from both the pictures on the left and right hand side, that we have serious issue in India particularly, and therefore we have to do a much larger, sort of effort to make sure that we improve, and we improve definitely, and there are ways and means to do it. And also, I must say that at all levels, the desire, the aggressiveness, that, and then the urgency to clean the air is very much in the country, which is very, very positive thing. And apart from that, on the right-hand side, you see there are certain, well, of course, we all know that called diseases, called the mortality, many strokes, cerebral strokes, heart disease, ischemic heart disease, lung cancer, COPD, and respiratory infection. So these are all have been very well identified and have been, documented at different levels and published in top journals. So these issues are sort of not there to sort of discuss or question them, but regardless, what we want is a better air quality, and that would be for the entire mankind, as well as particularly the benefits that would come would be much larger to our country. Further, issue of PM 2.5, all of you understand what is PM 2.5, but still for the sake of, the many participants who may be there, and the PM 2.5 very tiny particles, 1/10 of this, even then smaller than 1/10 of the size of our human hair. So these goes deeper in the lungs, cause a lot of problem. But interestingly, if you look at the PM 2.5 under microscope, you do not find that it's really a sphere. So the bottom, what you're seeing on the left-hand side bottom, the particle look like, if I can use that word, it looks like essentially popcorn, with large surface area, it carries a lot many toxics. So the ways that we want to handle this problem of air pollution is to sort of apportion the sources who are contributing to us. So then only we know which sources are responsible at the breathing level air quality. See, we don't want to go very high up in the atmosphere, what it really matters to the public health is the breathing level air quality. So break down the complexity, which is on your left-hand side, little filter, which has many things, break it down to the various sources. And this is what is at the many level, the many institutions, Central Pollution Control Board, Government of India, many state governments are doing the same thing, are trying to identify what are the sources actually. So why I again say, well, this is the time that we are at the juncture where we have to really seriously focus onto the pollution control. If we don't, these are the baseline scenarios or business as usual that what might happen. So you see already in the Indo-Gangetic Plain or Ganga Basin, we have very high pollution levels. And they're going to expand, they're going to increase in length and breadth. And many other cities and many other areas would become more polluted if we don't do anything. And by 2040, situation could be even worse. Well, these are just the projections. But the point is that, well, again, significant point is that, well, we have to act now, because there's no more delay we can do. And as I said that, well, everyone is serious. This is the profession I'm in, and I can see at all levels there's a great urgency, which is a very good thing to do. So now the question comes, why we talk about the vehicles so much as opposed to many multiple sources. So you see that two pictures on the screen that you're seeing. On the left-hand side, it is just showing the various contribution of the pollution. This is study from Delhi. So you see the gray kind of thing on the right-hand side of the left-hand side picture. The vehicles are contributing on an annual basis only about 14%. And then the argument can be there, well, only 14%, and as to why, certainly entire focus or the greater focus has to be on the vehicles, the answer is the second picture. See, interestingly, what is happening is the pollution sources, not only their mass or quantity, it is their chemical composition that governs the toxicity actually. So if we translate the mass into the toxicity, you see here, this is showing you the lifetime cancer risk, incremental cancer risk, if you like. So you see here the diesel component, which is again from the vehicles, and the gasoline, if you can see, is about 8%, and even CNG for that matter. So you see that there's a disproportionate increase of the vehicle contribution when it comes to the toxicity, and that's what is important from the health point of view. So let's move on this one as to what we have been doing. The massive thing, or really remarkable thing, I must say, that has happened is that we are doing very seriously about the vehicular pollution, and we have moved leapfrogged. We all know that how quickly we have jumped from BS4 to BS6. We have really skipped BS5 actually. That's really good news. And while it'll take some time, by the time the BS6 fleet, they make their inroads onto the road, but we have to wait for that. But the tone is set, and we are going in the right direction. But the point is, we also need to see that how we can make things even better. One is that as the law is the following things, or things which are on the downstream, what we still need to do, and whether we have done the major investment, but this is the time to do, even if it requires a minor investment, but the advantage or the benefits that would accrue, as I said in the beginning, can be enormous. So what we do is that certification and homologation, you all know about this. On the left-hand side, typical picture I've taken from a friend from ARI. So they do this thing, and even ICAT does this thing as to test the vehicles. And so for testing the vehicles, what you require is a certain cycle of operation at the laboratory level. To start with, I would sort of draw your attention onto the blue lines. That was our IDC, that's our Indian driving cycle. So that was sort of modified, and what we got is MIDC, because this was the time period was short, the speed was shorter, and therefore we could not capture the emissions correctly as to what would happen if the vehicles move differently than what were the driving cycles. So obviously then we move it to IDC, and IDC, which is sort of, MIDC, that's a modified Indian driving cycle, which is red or sort of orange color. That's we did pretty well in the sense that we did go very close to NEDC. That's the new European driving cycle. So we kept trying to capture the more thing. But as the science progresses, as we know more about the things, we come to know there's always scope of improvement. So if you see the bottom picture, that's a very interesting picture. You see on the center of this one, that is largely the MIDC. So that is what is the cycle that we're operating, modified Indian driving cycle. But if we actually look onto the road, what is happening between the speed and the acceleration, there's a wide range, both on the deacceleration side, which is negative on the left-hand side from the center, and the positive thing. So what is happening is we are just, about probably the testing procedures are not even capturing what is happening on the left and right-hand side, actually. And this is a typical picture of our cities. So therefore, the question arises, well, is MIDC is good enough to say that our vehicles are good? Undoubtedly, our improvement has been tremendous, but then we have to really see how would they perform once they're on the road. So these pictures, while giving you the background, as well as they also say, well, we certainly need to go ahead and go forward beyond MIDC because we are not quite capturing the acceleration and the speed, which is a very important parameter. So this is another picture, same, whatever we are feeling now, the Europeans, which we tend to follow, they had this similar situation, and they thought as the vehicle technology is changing, the speeds on the highway is changing, and so they also thought about the same thing, and they come up with what is called as WLTP on the top, actually. And there are 3 cycles. Let's not worry about those 3 cycles, but they have definitely modified. So what they have done, increase the time scale, increase the speed range, and have the 4 different sort of slabs, if I can say, of how the vehicle should be tested. So they come up with a new system or new WLTP, which is sort of procedure. And within that procedure, what would be there? There will be different cycles. So on the bottom also, the interesting things, once the WLTP3 is, you see it covers large range of acceleration, both on the positive side and the negative side. So we are tending, even the laboratory testing, that we are going more toward the realistic side. So in summary, what is happening if we compare the 2 cycles, NEDC, which India is closely following now through MIDC, as I said, but there's a lot of differences between an NEDC, which for us is nearly MIDC. So this picture is showing there are many changes that we have to bring to be a world-class testing procedures. So I don't want to go into the specific details, but let's take any example. For example, we take the average speed. So NEDC is capturing about 34 kilometers is the average speed, whereas WLTP goes to more than 46 kilometers per hour. So what we need to do is also very thoroughly examine WLTP, and probably it will fit very well to what the new conditions are there. And therefore, there is a need that the question that I pose is, should we not move to WLTP or equivalent in a reasonable time frame? We know that things cannot be changed overnight, but this is the time to very seriously look into these things. So when we, as I said, the technology, the understanding increases. Now the question comes, well, even we are going with WLTP, there are still questions, there are still issues with WLTP, and the general scientific community is asking, well, what about actual emissions on the road? So that's what we call it, real driving emissions. So for that one, and they may be very different because our road conditions are different, our acceleration, deacceleration procedures are different, our highways are different, the speeds have increased. These factors, the vehicle is driven all through. It's not that when the vehicle is expected to be on a particular road all the time of particular conditions. So the left side picture shows how we have to really drive the vehicle before it is sort of, certified under different conditions. And what we need to do is that that equipment, that is portable emission monitoring system, need to be installed, and we have to continuously measure the pollutant concentration under different conditions. And obviously, we have to make sure that we are able to sort of analyze the data, just to make sure that, well, while the vehicles are on move or expected to be moved when they come onto the on the road, how would they likely to be performed? And we have to make sure that these testing are done so that the vehicle that's coming out from your factory is sort of ready to go vehicle, even on the road while realistic, on the road. And then even at that time, the emissions are held back within certain limits. So that is the idea of RDE. And again, RDE is not a simple thing. Of course, it is challenging. Therefore, we are discussing it. because we require a trip selection that I've talked about with the map. It concerns the overall traffic, and our traffic is very different actually. We all know that how challenging our traffic could be. The physical conditions, temperature, pressure means altitude I'm talking about, humidity, road conditions, fuel composition, engine technology, OBD stands for onboard diagnostics, and the PAM's response. PAM's response is also very important because, the response has to be instant because vehicle is moving and response time is slow. So the PAMs, even though they can be of very good quality, but there could still be certain uncertainty. So just to give you one example, this right side picture shows how the altitude can vary and how the emissions could vary. So therefore, these realistic situations, what we are going to encounter in our country, that must be somehow be looked into, and in a reasonable sense should be part of real driving emissions. So again, there's another important parameter which is about the conformity factor. The conformity factor is a factor which is not to be exceeded, having accounted for some variability in PAMs, because the PAMs, there's uncertainty there. So that factor to the emission limit actually. So that factor, generally the conformity factor would be more than 1 because we are accounting for the uncertainty. So this is just a picture which shows with the new and old vehicles, this is the limit, let's say for the NOx, this is the European limit, and the allowable can be a little bit larger, while this is only true for RDE, not for the test. And these conformity factors have been decided by a few countries, and they are constantly revising them as the PAMs become a better machine to measure the pollutants. And then finally, this is the something, emission also greatly relates to the velocity multiplied by the acceleration, because that's where you see if you are at the low velocity and you're just accelerating very highly, there'll be a lot of emissions, and similarly at the higher speeds also. So this dynamicism of the whole process has to be captured properly even in the system of RDE. I don't want to go into the details, but this is a little bit of statistics there. 95% confidence interval between the blue and the red thing should come. And RPA stands for rate of relative positive acceleration. So this is a three-way graph. If you can see, velocity on the x-axis is the velocity, on the y-axis on the left-hand side is velocity multiplied by your acceleration. Okay, so that determines. So this is a very important thing that we account for all these things to get the rightful RDE. This is a summary of what I said. Well, this is how the Europe is progressing, and they are constantly moving ahead, to make the better emission control technology, engine technology, and therefore even we have to follow something similar. We might do of our own choice or own requirement, as we say, but the RDE emissions, which ICAT is working. But the point is that what do we include in there actually? How do we make our RDE more robust, more effective? So I don't want to read that, but what the point I'm trying to make is we should have a larger consideration for the pressure, which is altitude. So we have to go all the way because our country is very large. The temperatures, we have sub-zero temperatures. Our limits for the testing has to go all the way up to 0 degrees Celsius, because there the emissions would be large, hot start, cold start, and that kind of thing. And as I said in the beginning, we have to move to WLTP. Speeds have to go up for the testing because our highways are now going maximum to 120 kilometers per hour. And then the rush hour, low speeds we have to test, because most of the time as we go routinely daily to our office, that's where we are going to encounter the maximum emissions. So that should also be part of RDE. PAMs that I talked about, their sensitivity, their good quality, their specifications have to be brought in, have to have the right test. And then finally, we have to, we also have, due diligence with MPFI, and that has a lot of potential for reducing both particulate number and particulate matter concentration. And we also need to very carefully and very properly and very progressively, if I can use that word, decide or to the conformity factors actually. 1.5 or whatever, that we need to discuss very properly, and all the important stakeholders should come onto this one, because that is going to the conformatory factors are going to decide our emissions, and then how important is emission to the health of the people and all that I very briefly talked about. And finally, road maintenance. These are the issues which we must handle very properly. I mean, they probably do not require technology. They are just simply many management issues on the road. I mean, I just thought even maybe it's not part of RD, but I must include that. So this is briefly my presentation. I would like to stop here and thank you very much. And I'll be very happy to entertain any related questions you might have on this subject. Thank you very much.
Thank you. Thank you very much, Dr. Sharma. That was a very detailed presentation on several factors. I mean, we do have a couple of questions, which we will, of course, take later during the program. I'd now like to invite Dr. Thorsten Boger. Dr. Boger, the screen is all yours.
Okay, so thank you. And also thank you for kind of letting me talk at this event. And what you will see is that there actually will be probably some overlap of what Dr. Sharma just said, and I will kind of repeat it with my words. Overall, obviously, India has made significant steps when it decided to do the transition directly from Bharat Stage 4, which was roughly equivalent to Euro 4, to Bharat Stage 6. And I'm kind of happy to provide some overview of how we at Corning see regulations in other parts of the world evolving, and I'm hoping that this might also help the further development in India. As a quick comment, so I will focus a little bit on the passenger car side because that's the sector I'm mostly following in my current function within Corning Environmental Technologies. However, the same general thoughts obviously apply also to heavy-duty applications. Now, looking at the current and anticipated future emission regulations from a global perspective, what we can say, and I think it has been said before, is that Europe is leading with respect to emission control requirements. And as an after-treatment component supplier, the majority of our new products has and is developed for needs driven by new EU regulations. Therefore, and since India is, as Dr. Sharma just showed, is mostly following sort of the European trends or evolutions, I will provide first some focus on how this developed in Europe, and then also obviously expand to some of the other regions. Now to start, it's kind of that's looking kind of in the past, how it worked in the past was that the main focus of regulations has been to just lower the limit. So this is like the values in milligrams per kilometer that can be emitted, and then the performance of a vehicle has been evaluated on a chassis dyno, as Dr. Sharma just showed, over a predefined cycle, and we also have seen examples of that. And this testing is done in the lab, usually at the room temperature. The drive cycle used in Europe until Euro 6b, which was introduced in 2014, was the new European drive cycle, short NEDC. And you saw a picture just in the last presentation, which is a quite synthetic drive cycle with the two phases for urban and extra urban portion. And then as already shown, the cycle that India is still using today, the MIDC, is pretty much the same, with the main difference being the high-speed portion. And then in the early 2000s, so this was before Euro 6b, what kind of happened in Europe was that several organizations, there was governmental or non-governmental organizations, started to measure emissions of vehicles on the road under real-world driving conditions. This was possible because at that time, mobile emission equipment, the so-called PEMS, became available. And what was found was that in most cases, almost probably all cases, the emissions that were found on the real driving conditions were significantly higher than those measured over the NEDC cycle. And this observation then kind of resulted in a significant change with respect to the focus of new regulations, especially in Europe and now also in other regions, like India is doing the same. And so while there still are, like, from stage to stage changes in the numbers for the emission limits, the main focus now, at least that's true for Europe, is actually the driving cycle and how you make sure that these emissions are met in use. And we also heard about that already before. And the first step that was done in Europe, and that was then also introduced with Euro 6010, was the introduction of the WLTC. We just saw it. It's a much more representative cycle. So there was already a significant step. It's still done in the lab. It still follows a predefined cycle so it doesn't have any randomness, so it's very predictable. But it is more representative of compared to the NEDC. And in China also adopted it with the introduction of China 6. But the second, it's the much more significant step, was this change to in the direction of how to test. And this was the introduction of so-called real-world driving emissions testing, which we also already heard about. And these procedures have been introduced in Europe already in 2017. There was what we call Euro 6D temp. So Euro 6 was fragmented into many letter versions, subversions, and Euro 6D temp 2017 was the first one, and China will do so with China 6B, and then as far as I know, also India as part of Bharat Stage 6 in 2023. And the emission assessment is now actually performed on the road under more or less random driving conditions on public roads. So it's not defined by speed trace or cycling, but it's just defined by a set of boundary conditions. And the boundary conditions are meant to kind of describe what we would call typical or normal driving, and try to exclude abnormal or like very excessive accelerations or driving behavior, or very extreme climate conditions that are not typical. Today, the majority of the discussions we have for Euro 7, so that's the next stage in Europe. We don't know exactly when it will come. We expect it now for 2025, 2026. Is actually, I mean, there's still some discussion on the limit values, but the majority is around these boundary conditions and what should it include and what should it not include. That's the majority of the discussions. And as already said, we do know that the majority of emissions of modern passenger cars occurs during or in relation to the cold start of the engine. And this is relevant because this actually occurs in areas where people are present and are directly exposed to these emissions. Examples could be parking garages or along the roads or living quarters or streets. And therefore, it's essential that when we define these RDE procedures and also the way the data are analyzed and kind of converted back into a simple number, that we do it in a way that we are capturing these cold start emissions well, and we are not diluting them as a result of most RDE cycles are very long. So you have a lot of kilometers to kind of dilute this initial cold start period. So it's important to not dilute them, but kind of consider them in a meaningful manner. In Europe, this has been done with what we have now for Euro 6, with what is called the RDE package 4. And then, as I said before, for Euro 7, this is currently under kind of major revision to be, allowed. Basically, these boundaries are opened up to allow more driving conditions. With respect to the ambient conditions, and Dr. Sharma already highlighted it, I think it's really important to cover all relevant ambient temperatures. And traditionally, testing was done at room temperature on chassis dyno or lab, which is 23 degrees Celsius roughly. And we all know that in Europe, and I think maybe it's the same in India, the average temperature is well below 23 degrees Celsius. So we rarely have these temperatures. And actually, in many areas, also the average temperature for a significant number of days below zero. So we also have to consider below freezing temperatures. And as we just saw, it's actually quite similar in India. And I do hope that this fact is considered here as well to provide for robust regulations. Then another brief comment, it's also fuels. The fuels on the road, so RDE testing should consider for the actual fuels available at the pumps, which all have to be in spec. But we do still see quite a variety in fuels. And we do know that especially with respect to the particle formation, the fuel can have a huge impact, and the factor of 2 to 3 are not uncommon between like a reference fuel and still one of the more particle forming pump fuels. Another one, and we saw it, and it was already shown as the V8 POS, is the driving dynamics and load factors. And quick accelerations, as we saw it also in this picture for Indian use cases, are actually quite common. And in general, they result in higher emissions just because of the dynamics and transient of the combustion process. And so this is something where the NEDC or MIDC in India was definitely not representative. The WLTC is closer, but still it's much milder compared to what we do see under real world driving conditions. Another one that is under review in Europe, and it's important to use it in a meaningful way, is this conformity factor. And Dr. Sharma showed the different values. The concept of the conformity factor is absolutely valid. It's meant to consider for measurement uncertainty. It's not meant to allow for higher emissions on the road. So it's meant to be for the measurement uncertainty. And today, we do know, based on a lot of work done by the Joint Research Center of the European Commission, that this CF value for NOx and PN is well below 1.5. And in Europe, it's kind of is adjusted on an annual basis. And the idea is that we are supposed to move towards 1, meaning no extra factor, but it's definitely not 2 or higher, but it is actually below 1.5 based on measurements. And then finally, one area I almost forgot to mention is that limits should be independent of fuel or combustion technology. So it should be equal for gasoline direct injection engines, port fuel injection gasoline engines, or diesel engines. It just should be equal. And this is something that was clearly missed in Europe with Euro 6, but I'm very certain that this will be addressed with Euro 7, and then China already recognized it and included it in China 6. And then in North America also, this has been the case all along. There's one regulation for any type of combustion engine. So I would hope that the learnings made in Europe and also the other regions are kind of recognized and considered when new regulations are introduced. And especially with respect to gasoline engines, we do know, for example, that the port fuel injected gasoline engines, which are also excluded, I think, in India for now for particle numbers, they actually have very high fine, like on the very fine particle side, the very high emissions and should not be neglected. Now, looking at the other regions, what we do see is that China usually follows a relatively close trend with Europe. Typically, we see 2 to 3 year offset and then some adjustments to consider for regional differences. And then what we see right now today with the China 6 regulations, they are tighter in some areas, for example, some gas pollutants, and then also this fuel neutral approach. In some other areas, they are a little bit more lenient, like the determination for a procedure for real world emissions, which is putting a little bit less emphasis on cold start emissions. And as far as I can tell, I think India is on a similar path. And I think it was mentioned already, at least as a reference to Amir Joshi or Willard Cutler, was that the good thing for India is that all the technologies needed, they are available. And since India is kind of trailing still behind, they are available. They are proven on millions of cars and for many years. So it's technically possible. There's no invention needed. As a last major region that is following kind of a little bit set of different regulations, some words about North America. North America, the focus always has been on a very tight limits for gas emissions. So that's hydrocarbons, CO, NOx. And with respect to these gaseous pollutants, US EPA or California Air Resource Board basically have had the toughest regulations worldwide. And the numbers remain the toughest. But they are still using a fixed drive cycle, the FDP 75. And so what we do see is when we compare these low emission values combined with a fixed cycle, it is less challenging than some of the RDE cycles we are looking at. These emissions actually become less challenging compared to what we expect for Euro 7. And then another observation that we have is that in North America, still there's a focus on the particle mass measurement, which is less sensitive to particle number measurement. And so this remains an area where there's much less focus for the regulators. And what we do see, and that's kind of my final closing comment, is that we do see that vehicles, identical vehicles sold in Europe and in the US, basically come with a GPF in Europe, significantly reducing the harmful particulate emissions, whereas the same vehicle would have no GPF when it's used in North America. And this includes vehicles produced in the US and then exported, for example, to Europe. With that, I want to close and look forward to any questions that might arise. Thank you very much.
Thank you, Dr. Boger, for your perspectives on the subject today. I would at this stage like to invite Mr. Sudipto Basu. Mr. Basu, over to you.
Greetings to all. I hope I am being heard. Is it
Yes,
okay, the voice?
yes. Voice is
Uh,
clear.
uh, very good, very good. Greetings to all. And at the outset, I have to thank Mobility Outlook as well as Corning for giving ECMA this platform. With that, after the very informative discussions and presentations by Dr. Sharma and Dr. Boger, who focused quite strongly on test procedures, which are also very important, because first of all, to be able to have a good idea or good control over emissions, one needs to be able to measure them correctly. And as we know that as India has moved over the past 30 years, when it first regulation started with BS1 to BS6 currently, uh, there have been small changes in the test cycle, and the major one came when we moved from testing in the lab to real drive emission testing, which is expected to, which should be commencing from April 2023. But moving away from a little bit from the test procedures, I would like to speak a little bit on what India should be probably looking at to be able to ameliorate the air quality in its cities. And as in one study done by IIT Kanpur some time back, we know that almost that 14 Indian cities were among the highest polluters in the world. And I'm sure that even today, there would be, if there was a measure done, there would be quite a large number of cities still continuing in that kind of category. So emissions control, for which a lot of our member companies are working towards, is a very important subject. And along with that, as we are seeing today, the focus is shifting a little bit away from fossil fuels to more cleaner fuels like CNG and biogas. We know that CNG has already come in quite strongly in the cities, especially for public transport. But the government is pushing also very strongly towards biogas and flex fuels. Along with that, there is a move also to electric vehicles, but I will not talk about that because that has its own set of problems and issues, and that's a parallel development. As we probably know, various forecasting institutions have forecast uh, diversification in the energy sources, and the fossil fuels will continue to be one of the major contributors to this mobility for quite some time to come, along with different types of cleaner fuels, biofuels, CNG, hydrogen, and even EVs. In the Indian context, what seems to be missing is the hybrid. We do have some small portion of mild hybrid coming into the Indian market, but what I see in Europe and even other places, full hybrids are growing quite strongly, and rightly so, because in my opinion at least, uh, well, I said EVs have their own set of problems. Even CNG and biogas, as well as biofuels, uh, do require after treatment. They have particulate emissions which need to be controlled. So maybe a right direction would be a mix or take the advantages of both fossil fuels as well as electrification, to be able to have a hybrid, because it is from an after treatment perspective easier to control pollutions from engines which are more or less moving in a fixed range in terms of load range as well as speed range. So that is something which I do not see on the Indian market yet, probably because of the higher costs, which I'm sure various OEM would be interested in working on to see how hybrids can be made more affordable. Now, coming to the other, coming to first, let's say fossil fuels, we have seen the diesels coming down from about 50% market share in India to almost 15% now. But having said that, with the BS6 after treatment coming in with particulate filters in place, I am sure that the the levels of particulates will be much reduced. And as we see more and more BS6 vehicles coming on the road, there would definitely be an impact on the environment. And perhaps after a while, a study needs to be done to see how this is actually changing the environment, the coming in of more and more cleaner vehicles with BS6 after treatment technologies. Perhaps this will help towards improving the pollution levels. Gasoline is gaining popularity with gasoline direct injection vehicles, which are also coming in. But as we move towards both gasoline and even CNG, particulate emitted from these engines become a concern because they are not only smaller in number, smaller in size, but also larger in numbers. And therefore, as we just heard Dr. Boger talking about gasoline direct injection engines fitted with particulate filters coming in Europe, that is something that needs to be also probably seen in India as in the future, both for gasoline as well as for CNG. Biofuels coming in would require again some form of after treatment for NOx as well as maybe also particulates. And luckily for us, as we have heard earlier, India is following in the footsteps of Europe. A lot of technologies have already been developed for the other markets, and ECMA member companies, I'm sure, we are well equipped and well positioned to get them into India as and when they are required. Now, having said that, in terms of the regulations, as rightly pointed out, India is still in the testing of according to the MIDC, and we need to quickly move towards the harmonized test procedures, which is WLTP, which is coming in. And here again, we have the guidance from Europe, where Dr. Boger spoke about various learnings that have taken place there, which should come into India. And I'm sure that we would also be moving in that direction, maybe a little bit slower, but definitely that is a direction that we should be taking. With that, I would say that in terms of technologies for heavy duty engines. Now, heavy duty engines are trucks and buses, which form a large portion of the diesel population in India. And although in the cities we have moved away from diesel fuels to CNG, and more cities are coming into the CNG ambit, long distance trucks and buses which move in and out of cities at certain times do contribute to pollution. And so with BS6 coming in, even for diesels, the need would be to move or to move towards BS7. And we just heard about BS7 being talked about in Europe. There is a bit of, I see, delay, I think, for BS7 coming into Euro 7 coming into Europe, but definitely India should be looking at the next stage of emission norms, moving from BS6 to BS7 through the changes that take place to BS6, that is the moving towards real drive emissions, both for light duty as well as heavy duty, and then move towards BS7. What these changes or these measures would do to improve environment is a big question, and that is something that needs to be looked at in more detail. I understand today there are institutions that are doing tests and measures to see whether these efforts are being really being productive in terms of the aims and objectives they're supposed to do, and that effort needs to be intensified. And from that perspective, I would say that it's not only government, but even institutions like CPCB, maybe even ECMA, needs to find ways or put in resources to see how we could really see and demonstrate that more and more control of exhaust emissions from mobile sources are really improving the environment and having an impact on ameliorating the health condition uh, that would result with this control. So with that, I would like to summarize my brief talk and invite questions uh, as as from anyone who is interested. I mean, Deepangshu, maybe perhaps we could move into the question session.
Thank you. Thank you, Mr. Basu. We indeed, we already have quite a few questions from our participating delegates. I request you to continue sending in your questions, but I would start with you, Dr. Sharma. I mean, you made some observations and you did say that there is a very strong desire in the country today to ensure that, that's a very strong desire to ensure that we have, better controls over the emissions that we have in the country, and then measures are being taken. Now, when you talk of the specification of PEMS, for instance, as a country, where are we with publishing of standards or the specifications of PEMS? Could you give us an idea on that?
Well, yes, as I said, this was the most critical thing when we are going for RDE, because if we can't measure properly or there's some uncertainty is there, then we are sort of in a bit of bother. You see that we have good measurement system now for the ambient air quality, but to see and to capture at the source level, I would believe that should be slightly easier because the concentrations levels would be higher. But we also have to see there are some issues involved when we are doing the PAMs. What happens, there are a lot of emissions which are sort of in the vapor form, and as they come down from the vehicle exhaust, they would turn into the particles actually, as there will be some condensation, there will be some other physical processes, even nucleation for that matter might happen. So as a result, we need certain space or some sort of dilution tunnel in the process. So that is what is also a very important component. So there must be some validation and very thorough validation by certain agencies to make sure that the PAMs have right specification, right kind of quality. So that process is still, in my knowledge, is still not in place actually. So that is very important. But there are ways and procedures that people have done the studies, and there's a good science as well as the good measurement techniques behind them, which are there. So we have to have the right specifications, that's for sure. But this is something very important area immediately.
Okay. I'd also like to take a question that we received from Mr. Prakhar Singh. He wanted to know, while you're making your presentation, sir, why India has not matched the PM quality measure with WHO? Why do we have such a variation according to the global norms?
See, right now our emission levels are very high, and we must reduce it in a very progressive manner. The pollution control measures or efforts take long time. They also cost us a lot of money. And at the same time, like we have to have some balancing act between the growth of the economy as well as to bring down the pollution. And certain areas we are stuck with a lot of poor meteorology or poor dispersion. As a result, even if we are taking a lot many actions, those things would not be reflective. So we have to take the multiple stakeholders along and to decide our own standards and simply not go by the international the norms actually. That is one thing. But what I can share with you that right now we are CPCB has announced or given the work to us to relook or recalibrate our air quality standards. And we are looking into it, and we are trying to say that what best and how best we can do it given the health criteria and also the requirement for the country in terms of the investments that we can do.
All right. Dr. Boger, I have a question for you. I mean, you did talk about emission control tech from a fuel perspective. You gave us an understanding on that. But how do you see innovations and improvements in fuel technology leading to lower emissions in times to come?
So, I mean, what I meant was that we do see within existing norms quite some variability in the fuel quality, and quality not being good and bad, but basically the core composition. So we know that gasoline, for example, with the high aromatic content usually results in higher particulate formation.
Mm-hmm.
Now, for what we do see is in Europe also there's quite some interest, also with respect to recent events, there's some interest in moving also to synthetic fuels, which are likely lower in their particle formation characteristics,
Mm-hmm.
and also because you can better control also. I think it's especially usually the aromatic content that is at least for particulates
Mm-hmm.
concerned. So I think there's some direction towards synthetic fuels, and then I think ethanol. There's some debate, but I think in general it doesn't hurt. We see slightly lower particle formation, at least within the lower range before the combustion gets too cold. So we do see some direction there, but I think it's what we see as emission control player, we don't see much of the activity. I guess it's happening at the oil companies where they are kind of also working towards it. And I don't know if it's emissions or if it's mostly driven by CO2. So we've not talked about CO2 today, but it is driving a lot of our powertrain, and then also fuel development is kind of trying to lower the CO2 emissions, which are not like a pollutant, but they're concerned for kind of other reasons. So we see some, we don't see a lot of dedicated development to lower emissions, mostly for other reasons, but I think synthetic fuels have some potential here.
All right. All right. Mr. Basu, I mean, you're free to comment on this question that I had, of course, on improvements of fuel technology per se. But there's another question that we have from one of our delegates who wants to know which of the factors will play a vital role for India to reach net zero emissions. Is it electrification of vehicles or decarbonization of the grid?
That's a good point, because you see, electrification of vehicles, first of all, would require power, that is electricity, to be available and to generate that. Today, I think India uses almost 66% of the power comes from coal generation, from coal power. So if that is the case, then to move towards net zero, although you would be, if you go to electric, 100% electric, the amount of, and if you don't change to your generation to renewable sources or even nuclear, was one of the options that Europe is talking about now, or even hydroelectric, then your net zero emissions would not be addressed, because to be able to generate the power that you use in the electric, although you will be reducing the emissions from sources in the cities, you will be generating that elsewhere. So the decarbonization of the energy sources, to me, would seem to be more important than actually moving directly towards electrification, because this is a question that has been discussed quite extensively by everyone as to, are we really moving in the right direction when we jump towards electrification? It is very simple to say that, okay, we move from fossil fuels to electric and we become absolutely carbon free. It is not the case. It is not a switch. You cannot just switch on from switch off one and switch on the other. You have to transition through phases, and there is a path that needs to be followed, so that you take care of all possible sources. And to me, it would seem that a decarbonization of the grid by relying more on renewables, by relying more on non-coal energy, renewable sources, wind energies, and whatever is the direction that we should be moving in.
Dr. Sharma, I mean, your comment on the same subject really in terms of how do you see this panning out in the future? Decarbonization of the grid, of course, is an important part, when we talk of lowering overall emissions from various factors. What's your final comment on that?
Yeah, I completely agree with Dr. Basu. Well, the grid thing, because when you're moving towards electric vehicles, you also need more power, and the power has to be, the larger share has to be from the renewables, and that's what exactly, in fact, is happening. Not only the government, and also the new technologies from the solar generation, that is making the power very cheap as far as the solar system is concerned. See, the point, I mean, of course, the IC engines would remain for quite a while. But what people are really looking towards the electric vehicles, or in fact even strong hybrids, is actually the point is that, well, these vehicles are sort of agglomerated or concentrated in the urban areas, and they are causing the problem. Maybe if you look at the pan-India scheme or of the distribution, the vehicles may not be contributing that significantly, but our hotspots are the urban areas. So therefore, the people think, well, if we can generate the electricity, and that too through decarbonization, that is very good. That's a win-win situation. Actually, that's what the people would argue.
Right.
But very quickly, the point is, while we are going, renewables, but at the same time, our power requirement or the demand is increasing. So then we are like sort of a double edge kind of thing. One side we are going renewables, well, very good, but at the same time, power requirement is going up. That is being filled by the coal or the fossil fuel. So in fact, while our percentage of the renewables may go up by 2030, but the overall power generation is expected to be higher from the coal generation than the renewable section. So that is what is the situation.
Okay, gentlemen, we have run out of time. Yes, Mr. Basu.
Just one more point. One more point. There was one question regarding emissions from mobile sources, that is especially tires and dust that is kicked up by vehicles, and that is another important point, because I think that is an area which is not being addressed at all. Tire wear, particulates emitted by tires, as well as the dust that is kicked up, something which is underregulated today, and I think that is another thing that needs to be addressed.
Sure. We have run out of time, but what I'll do is I'll just quickly go around this panel for your final comments on the subject, right? So we're discussing emissions, air quality, and health. Why you should care. Dr. Boger, I'll start with you. Your final comments on the subject today.
So I think what we see in Europe is that there is regulations, but there's also a trend towards zero, what we call, not in a formally defined way, zero impact emissions. So this is also to have the discussion versus electric vehicles, is that we kind of view it as try to achieve what is possible. I think that's it has been demonstrated versus just barely meeting what is required. I think that is something that has been some sort of a trend that we observe in Europe, and I think it's a good thing for us as we live here, and want to continue to live here healthy.
Thank you.
And thank you for the time.
Yeah, Mr. Basu, your final comments, sir. You're on mute, Mr. Basu. You'll have to unmute yourself. Yeah.
Sorry. Yeah. As engineers, what I would like to say is that we have been actually learning all the way, right since the 1970s, when emissions control, harmful emissions got recognized and started getting controlled in North America. There has been a lot of learnings that have taken place, and we are still in that phase. And therefore, it will be a long time before we can really move towards zero net zero emissions. And let us then give everybody a chance to improve, work, and come towards the final solution of net zero emissions. It's not just electrification or fossils or whatever. Everything needs improvement, everything needs work, everything needs engineering, and we need to do that to be able to move towards a cleaner and healthier environment.
Lovely, wonderful. Dr. Sharma, your final comments.
So primarily, we control emissions for the good health. Actually, that is the first point. Actually, and that we all want to be very healthy, and not only current generation but the coming generation. We all should be healthy. So that's point number one. Point number two. I mean, when we talk about the controls, where to do, there has to be a three-pronged, strategy. At the national level, some decision has to be taken right at the top. Second, at the regional level, maybe the states or multi-states coming together. And third thing is at the city level, or the micro planning that is required. So and then all these three things have to combine for the better air quality. And this is time for, well, too much of analysis has gone into, too much of analysis lead to paralysis. This is time to act, actually, and seriously act on the issue. Thank you.
I mean, on that note, that's a wonderful way to actually conclude this discussion. The time to act, and the time to act is now. Gentlemen, thank you so much for being part of this discussion. Truly appreciate you taking time. Thank you very much.